All right, so far derivative rules have been pretty easy. So if you're asked to take the derivative of two things added together, you can just differentiate it piece by piece, right? What if you have a number times a function and you take the derivative?
Number times the derivative of the function.
Number times derivative. So far those two are intuitive in what you expect, okay? So how about products? So I think everybody's first guess for products and their first hope would be that if you take the derivative of the product, it's just the product of each of the derivatives, okay? I'm going to tell you this is wrong. It does not work. And I can explain why it doesn't work with a really easy example. Okay, so pick your favorite exponential.
X.
X to the what power?
1.
Let's do something with a power bigger than 1.
X squared.
X squared, okay. So what is the derivative of x squared?
2x.
2x, okay. What if I wrote x squared, take the derivative of that, as the derivative of x times x, right? For my rule to be true, the derivative found this way should give me the same answer as this, right? So if you try to apply the rule where you differentiate the first piece times you differentiate the second piece, what do you get out? 1 times 1. Is that what we're supposed to get? No. So the derivative of a product is not the, write this down. The derivative of a product is not the product of derivatives. Okay. So it just doesn't work. So this rule is more complicated and is more, proving it is harder, but you're going to have to know this other rule. And this is a failed rule, doesn't work. Just like roots don't distribute, powers don't distribute. You think that you thought they would and they don't, so just move on and accept it. Here, the actual product rule. So the derivative of a product is f of x times the derivative of g of x plus g of x times the derivative of f of x. Another way to say it is if you take f of x times g of x with primes, this would be f of x, g prime of x, plus g of x, f prime of x. Would it matter if I wrote it this way? If I wrote it f prime of x, g of x, plus f of x, g prime of x, is that any different?
No.
No, it's not, because addition is commutative and you can change the order, right? So here's how I like to think about it. You have this product. What does this first thing say you're supposed to do? You've got a product of f times g, two functions multiplied together. Take the derivative of the first thing, right? Leave the second one alone. G means leave the original function. Plus, leave the first thing alone. Take the derivative of the second. And you're still multiplying, yep. And let's do it with x squared just to prove that it works, okay? So if I gave you x squared, which is x times x. That first x is like your f, the second x is like your g, okay? So this rule says take the derivative of the first function. What's the derivative of the first function? 1. And then the g of x part says multiply by the second function, okay? And then plus, leave this part f says leave first function alone, which is x, multiplied by g prime, which is 1. And what's 1x plus 1x? 2x. So it checks out and gives you what you're supposed to get. You would never differentiate x squared that way, because that'd be silly, right? But at least our rule seems to be consistent with what we know for derivatives here. And I'm going to say one more thing before I show you why it's true. The one additional thing is there's this pattern that you differentiate the first thing, leave the second alone, right? leave the first one, differentiate the second. How do you think it would work if you had three things? Say f of x, g of x, h of x. So you differentiate one function at a time. So like the first thing would be you differentiate f, you leave g and h alone. And then you'd leave f alone, you differentiate g, you leave h alone, and f as well. Then you'd leave f and g alone, and you differentiate h. And that's how it generalized if you had three functional multiply together. If you had four, you're going to do one at a time. You only differentiate one, leave the others alone. One, leave the others alone.
How many will we have on like
Oh, probably at most three, because it gets kind of tedious after that.
most three?
At most three. There is a homework question that has three, I know of, but I haven't written the quiz yet, so I can't say what's going to be there, but there is one with three on the homework. Okay. So here is why it's true. So if you wanted to find the derivative of f of x times g of x, I'm going to figure out the rule, you always start with that definition that we had. So it'd be the limit h goes to 0. What do you get when you plug in x plus h?
How many H's in there?
Well, if you're going to do the limit definition, you've got to do, function plug in x plus h, right? So it's going to be f of x plus h, g of x plus h. Like f times g is our function that's plugging in x plus h in. Minus plug in x, f of x, g of x, and all that business over h. That's like the definition of what a derivative is. Everything we know comes from that. Okay, so here is the really clever bit, and the reason I needed my notes, I have to remember to do it correctly, is to prove this gives the rule that we talked about, you have to add and subtract one thing. I'm not going to make you reproduce this, but it's going to be good to understand why that it works. So you got f of x plus h, g of x plus h, and you're going to take away f of x, g of x plus h, and you're going to add f of x, g of x plus h. I'm not going to make you reproduce that clever trick, but do you at least understand that it's okay to do that? Like, are those things still equal to each other? Yeah. It's kind of like completing the square, isn't it? When we completed the square, we added and subtracted something, right? And there was a pattern to how you figure out what that something was. There's a reason I chose this. But does it at least make sense that really these two things add to 0, and so this expression is different than the one above it? Okay. I'm going to break this into two pieces. I'm going to put the first two terms in one fraction, the second two terms in one fraction. So limit h goes to 0, f of x plus h, g of x plus h, minus f of x, g of x plus h, all over h, plus f of x, g of x plus h is f of x, g of x for h. And all I did there was unadd a common denominator, right? Now what can you do with each of those fractions? What are they? Can you make them look a little bit simpler? Anything you can factor out? The g of x plus h can factor out. Times f of x plus h minus f of x over h. Plus, I'm going to limit the second thing also. What's the greatest common factor there? Okay. Now, what you can do is limit each of the terms in this product separately. So as h goes to 0, where does g of x plus h go to? G of x. This expression, what's that the expression for? The limit as h goes to 0 of f of x plus h minus f of x over h, that finds the derivative, right? So the limit of that underlying thing is just f prime. That's what that means. If you plug in h equals 0 here, you just get f of x times g prime. So the rule is true because of the definition. Proving it is tricky because you've got to know to add and subtract the same thing. I've never come up with that on my own. I looked it up and someone cleverer than me discovered this is the way to prove this. But the point is that it all comes from that basic definition that we had way back in the first section 2728. And the limit of something that looks like this, that is what f prime is. That's what it means to be f prime, your limit of something like that. And these rules that we're going to learn come from that definition. Okay, let's use that product rule to differentiate this function. So we don't know what g of x is, but we know h of x is x to the third times it, and we're going to figure out what h prime of 3 is. So the first step is to get the derivative. So if you use that derivative rule, I think about it as differentiate one function at a time. So the first function is your f, second function is your g, and this will be f prime g plus f g prime. So what is f prime if the f is x cubed? And then the g of x gets left alone. It doesn't get differentiated. Plus, now that the g gets its turn, the x cubed gets left alone, and we have times g prime. So that's the derivative. Differentiate the first, leave the second. I just put x's in there, that's all.
Yeah, I was just
Yeah.
like,
What are those little weird
are these
things?
parentheses?
Yeah, no problem. But that's the derivative. Do you get the pattern? Differentiate one, leave a second. Leave the first, do the second. Okay, now if you want to find h prime of 3, what do? Plug in 3, yep. So h prime of 3 will be 3 times 3 squared times g of 3 plus 3 cubed g prime of 3. So that's 27 times, what goes in there? Five, good, okay. Plus 27 times 2. Here's a great trick. You can factor out that 27. That's not actually not awesome, correct. Well, whatever, times 7. Is that 140 plus 49? Does 189 seem right? Do you guys get going how I got 140 plus 49? Do you get how I got this 140 plus 49? I thought about 27 as 20 plus 7.
Oh,
I had friends who could do math in their head super fast when we were kids, and I never just figured out why or how, and that's how. They just were cleverer with numbers than I was. So, anyway, h prime of 3 is 189. What is the meaning of that? Like, we don't have a physical context, but what does that tell you?
That's a tangent line.
The slope of the tangent line. So since the slope of the tangent line is positive, your function's increasing at that point, right? It's going up. Okay. But the main idea is how do you get derivatives of products? Differentiate the first thing, leave the second alone. Leave the first one, differentiate the second, differentiate one component at a time. Okay. So if f of x is x e to the x, find f prime. And then find a formula for the nth derivative. I don't know why I wrote n so many times, but nth. So what they're looking at there is there's going to be a pretty obvious pattern if you take a couple derivatives. So we're gonna take like 2 derivatives and we're gonna, maybe 3, and we'll see what the pattern is. So first derivative will be, first differentiate x, you get 1 e to the x plus, don't differentiate x, differentiate e to the x, and what do you get? E to the x. Okay. So take out the greatest common factor and get e to the x times 1 plus x. So there's the first derivative. Doesn't matter what order I write those in? Not really, no, okay.
If that was e to the t,
If it was e to the t, then the x probably would be a t as well. Okay, for the second derivative, I'm just gonna keep it in the order I have it. Differentiate e to the x is e to the x times 1 plus x plus e to the x times, what's the derivative of 1 plus x? 1. So that's e to the x plus x, e to the x plus e to the x, or 2e to the x plus x, e to the x. Maybe this was better to leave this as e to the x plus x, e to the x. So there's the first derivative. Here's the second. Do you see there might be a pattern? Do you see that there might be a pattern? Let's do one more. What do you predict the third derivative is going to be?
3 dx plus x dx.
Let's just verify that that's true, okay? So we're going to check and see if that's right.
because it's an e to the x, it will always keep going. Normally, it would-
Yeah. But anyhow, how we would check using this boxed answer. So you can differentiate this sum as first differentiate this thing, then differentiate that thing, right? The first thing isn't tricky. What's the derivative of 2e to the x? 2e, that's just 2e to the x. But the next part, differentiating the x times e to the x, requires the product rule. So that will be 1 e to the x plus x e to the x, which is 3 e to the x plus x e to the x. So what's the pattern for the nth derivative? You could say it's n e to the x plus x e to the x, or you could say what I think Mary Kate said, which was n plus x times e to the x. Is that what you said? Something like that, yeah. Either way, but that's the pattern. So if it asks for the nth derivative, it's saying take a couple derivatives and you should start seeing a pattern. If it can be avoided, you should avoid the product rule. So for example, there were questions on your homework where you had a product in the last assignment. How did you deal with those? Like, how did you deal with something that was like f of x equals x plus 1 times x minus 3? You didn't use the product rule because you didn't know it, right? What did you do with that? Multiplied it out and then did the derivative. That's actually easier, so you can still stick to that. But the thing is, e to the x isn't a polynomial, so you can't multiply it out. Okay. All right, so if we have h of x is f of x times g of x, find h prime of 3, and I'll give you a picture. And you're like, holy moly, what do I do? Well, first of all, what is the derivative? What is h prime? Just give me a formula.
F prime g
Plus,
g prime.
plus f of x g prime, or g prime f, either whatever you want to say, it doesn't matter.
Yeah.
Yeah. Okay, so h prime of 3 is f prime of 3, g of 3, plus f of 3, g prime of 3. gonna make G red so you can see G better. Okay. So this is the derivative. What is the derivative telling you? The derivative is the blank of the tangent line. Slope. Okay, so if you're asked to find f prime of 3, this is my f function, right? Go to 3. Tell me what is the slope. I think you're looking at the slope of g. F is the lower function.
Negative 1/3.
Negative 1/3. Do you see your refund, guys? Because the g function is, or the f function is this guy. Okay, so the slope there is negative 1/3. And you think the slope is rise over run, right? You sink 1, you run 3. Negative 1/3. Okay? How about, what does g of 3 mean you're supposed to do? Log blah into g, right? So you go to 3. Is the y value when x is 3. So at 3, what is the y value of g? 3. Okay, plus, what does f of 3 mean? It is 1. It's the y value when x is 1 on the f function. So, or when x is 3, sorry. X is 3, the y is 1. And then what is g prime of 3? What's the slope of g at 3?
1.
1. So I believe this ends up being 0 in the end.
Yeah.
Negative 1 plus 1 is 0. But what that question is getting at, do you understand that derivatives mean slopes? Function with normal number plugged in just means what is the y value? Can you interpret a picture? What if one of your questions or things would somehow involve like doing g prime, f prime of negative 3, and you end up like with this point in there? Can you find the derivative at that point? Notice you'd say it was undefined, because one of the parts of your product was undefined. If it was the case you ended up plugging in a number where there was a corner, you took a derivative there. You can't take a derivative here, but you can like plug that number into the function. Okay, so that's the rule for products. Here's the rule for quotients. And I can only remember this one way, and it's silly and stupid, but it really helps, okay? So here's my acronym that you can choose to leave it, but I say it so often like this, you're gonna learn it if you don't like it. So think about this as the derivative of high over low. Do you see where those names could come in? High being the upper function, low being the under function? Okay. So this rule says you have low d high minus high d low all over low squared.
There's a song out of that.
You could, I think that there actually is a song out of it, but I refuse to sing in front of people. I don't really even sing. I sing in my car when the windows are up and I'm driving by myself, and that's about it. Not even the shower. But you see how this is the same thing? Low is the lower function, so low means leave the lower function alone. D high, what do you think that means? Derivative of the top. Minus high means leave top alone, right? Derivative of the bottom, all over bottom squared. Okay? You can technically also do quotients without ever using the quotient rule, because you can always think about this as f of x times g of x to the negative first power, and you can use the product rule on that. But you need something called the chain rule to do this effectively, which we're not going to learn until tomorrow. But you can always make quotients into products and use the product rule. That will also work. Just at this point in time, you might introduce something you don't know how to actually do yet by accident. Okay? All right, so I'm not going to prove this one because I proved one of them. So find the derivative of this thing. Okay, so y prime will be, and my little silly rhyme helps. So low means leave the bottom one alone. So that is x3 plus 6. So low d high means take the derivative of the upper one, which is 2x plus 1, great. So low d high minus high, which is, d low, which is,
3x squared.
all over low squared.
Can you just stop there? Or?
I want you to simplify. Okay, I know. All right, so is everybody okay with what I did, just the general first step, applying the formula? Okay. Now, I have this great little thing that's going to go on my door in my new office that says, whenever you can't do bad cancellations, you kill a kitten. It's a goofy thing. I don't actually believe in killing animals, but can you cancel this x plus this thing and one of those things? If you hate kittens. Now, so why can't you cancel this and one of those? What is the problem?
Because it's stuck in that subtraction there.
And there's nothing there, right? So that's the reason. Unless you can take it out or cancel it from both pieces, you can't cancel it. Okay, so don't do any of that stuff. All you could do from here is multiply out the numerators and then simplify. And I do want you to do that. Okay, I'm not sure if WebAssign will take it if you give it this. If you want to use one of your 5 chances to try, you can. Like, it might, but I'm not sure.
What if you broke into fractions?
Then you could cancel.
I don't think it'd help.
But I don't think it would really help. And in our next unit that we're going to do, it's going to be really helpful to have things simplified. So good to practice it now. So distribute this thing out, and you get, what, 2x to the 4th plus x cubed plus 12x plus 6. Take a second, think about if I did that right, because you know me and arithmetic don't always do good. Did I do it right? Okay. And then minus, I'm going to leave the parentheses there for just a second, 3x to the 4th plus 3x to the 3rd minus 6x squared. Does that seem okay? You all good? Don't leave your denominator off just because you're being lazy, like it has to stay there. Okay.
Are you gonna expand the denominator?
No, you don't have to. I don't, the reason really is that if you were going to see if the denominator had any kind of cancellations, you would leave it in factored form. So you never have to expand the denominators. You've got to expand numerators, but denominators no. So just leave the denominators alone, because they're already factored and perfect and beautiful. Now if we combine like terms, that negative will distribute, right? So if we do 2x to the 4th minus 3x to the 4th, I think we just get negative x to the 4th. Do you buy that? I think we also get negative x cubed. Negative 2x, I was just testing you. Yes? Okay, are there any squareds? And it's positive. And then plus 12x plus 6. Over x to the 3rd plus 6 squared. And that's just stop. Nothing's going to factor. It's just disgusting. So don't ever expand denominators. You don't have to. Just the numerators.
Okay, we'll never do it again.
We'll never do it again? Okay, good. Awesome. Let's work. Okay. Now here's my next note. Don't use the product or quotient rule unless you really have to. Here are some examples where you can use either, but it's easier not to use the product and quotient rules. The simplification is easier. So this one you could use the product rule, or instead you could distribute and just use the power rule. So what is root t times t? What power will that make? 3 over 2. Beautiful. Plus 5t to the 1 over 2. And then do you need the product rule? No. So then f prime of t will be 2 times 3 halves t to the 1/2, because it's 3 halves minus 1, plus 5 times 1/2 t to the negative 1/2. And I do want you to get common denominators. Like I'll make you do it in your quizzes about homework and WebAssign. Depends what the answer key says. This will be 3 root t plus 5 over 2 root t
Why can we write the?
Because it's negative.
It's a negative power, so it goes in the denominator with the 2. It's
Why
punished.
did you leave the fraction, that's one,
What?
fractional powers instead of going back to roots?
Oh, why didn't I leave them fractional powers? I guess with roots, I always just change them back to roots. As in with square roots, that is. I mean, cube roots and stuff, I just get lazy and I don't. But you could leave it as t to the 1/2, doesn't matter. Okay, how could you get a common denominator here? What would you multiply by? 2 root t over 2 root t. And so then your first derivative is 6t plus 5 over 2 root t. Okay, there you go. So the point is, you don't need the product rule and stuff like that. Distribute, use your power rule, it's easier. Part of the challenge in this section is recognizing what those problems are because they're mixed in with the homework problems. Okay, this one, do you have to use the quotient rule? Yes, you don't. Because this is a singular t to the 4th, you can write this as t cubed over t to the 4th plus t over t to the 4th plus 5 over t to the 4th. And that becomes t to the what power? The first one's -1. Second one is t to the, great. And the last one is 5t to the -4. And then you can just use your power rule.
There's homework questions like that.
Say that again?
There's homework questions like that.
You did. Yep, there were homework questions like that last time. -1 t to the -2 minus 3 t to the -4.
I always want to put 2.
I know, you have to think, think about temperature. If it's -3 and goes down 1, it's -4. That's the best analogy that I think I've come across. -20 t to the -5. And I would like you to get a common denominator, so -1 over t squared minus 3 over t to the 4th minus 20 over t to the 5th. What do you multiply the first fraction by? T cubed, good. And second one, t, last one, nothing, right? So y prime is -t cubed minus 3t minus 20 over t to the 5th. And if you use the quotient rule, your answer will look a little bit different initially, but it will simplify to this once you take out a greatest common factor and cancel it. So that it's because I want to make sure you know negative exponents go, I want to make sure you understand how they work. Yeah, so. And also we are going to do something in the next unit that it really involves, like, you have to have it simplified to work with it, and so it's just good practice to get over it and just do it now. By the time you get to that next chapter, you'll be good at simplifying stuff if you just do it every time. You could also kind of game WebAssign to see if you're right. Like if you know this is your derivative and you want to see it, because you've got 5 chances, you could put that answer in and see if it gives you full credit. And if it doesn't, try to put in this answer and see if that's right. You know the mistakes happen between here and here. That's one that you can use the system to kind of, and I'm pretty sure that it will take either answer. Like I don't think you have to do the common denominator in WebAssign to get it right unless it asks for it. But I'll ask for it on your quizzes, because I write my own directions. Yes?
Okay, that sounds nice.
Yeah, on the quiz, I think on the quiz today, I specified, where I said you have to get a common denominator.
And exams.
And exams will say the same thing, yep. But I will specify. Okay, this one, the product rule will work, but is a lot easier if you don't use it. Okay, so let's look at why. So if you multiply, what is z squared times z squared? Z to d, 4th. Plus z to z, sorry, I'm just being goofy now. It's a z squared root z, I don't know why I just wrote t. And then you're getting a minus z squared root z, minus z. And look at the z squared root z and the z squared negative root z, which really would have been z to the 5 halves, right? They cancel. So your function is z to the 4th minus z. So f prime of z is 4z third minus 1. A lot of those questions that involve multiplying are actually easier if you do so. Your book is trying to teach you a lesson. It's evil if you do it the other way. It's disgusting. It will simplify the same thing, but it's going to be gross. So multiply if you can. Okay. Can you simplify this one? Can you cancel those root x's? No, then you just kill the kitten. You wish, okay? That's killing a kitten. Don't kill kittens. The technical reason is PEMDAS is that fraction bar acts like a parenthesis, and it says do this before you do that. So that's the technical reason why you can't cancel those. So anyway.
What was it? What was it?
You have to do the operations in the numerator before you do the operations in the denominator. So you do operations in numerator, operations in denominator, and then divide your results. So it's an order of operations thing. So here you have to use the quotient. Well, it's going to get a little bit disgusting. So let's just do it together. So low, which is root x plus 1. D high, which is, what's the derivative of the, what's x to the 1/2 minus 1 over x to the 1/2 plus 1. So what is the derivative of the upper function? 1/2 x to the minus 1/2, yep. So low d high minus high. D low, which is the same thing, right? All over low squared. Okay. So you have root x plus 1 times 1 over 2 root x minus root x minus 1, 1 over 2 root x over root x plus 1 squared. Is everyone okay with what happened there? What happened there? Yeah, just made the negatives make into fractions, right? Okay. So what I see, you can look at this two different ways. You could take the 1 over 2 root x and you could distribute them. Does that make sense? What else could you do with the 1 over 2 root x? You could factor it out. So that becomes 1 over 2 root x times root x plus 1 minus root x minus 1 over root x plus 1 squared. Does that make sense? Probably is easier to take the greatest common factor out than to leave it in. Not necessarily, though. And then you're pretty much almost done. What happens to the numerator when that negative distributes? What do you get in it? I think you get a 2, and the root x's cancel, right? So you get 2 over, and this denominator multiplies by that denominator, giving you 2 root x plus 1 squared. So that's 1 over root x times root x plus 1 squared. And it's the derivative.
If you didn't pull that factor out, you'd be stuck.
I mean, it wouldn't be, it would, I can show you what it would look like. So if I hadn't pulled the factor out, you would have gotten, so here's the alternative. You would have gotten, so this times this would have been a half. Does that make sense?
Okay.
Because the root x's would have canceled. Then you would have had plus 1 over 2 root x. And then this times this would have made, and also bringing the negative in, that would have made negative a half. And then you would have had plus 1 over 2 root x, parenthesis, parenthesis, all over root x plus 1 squared. So far, you okay with what I did? And then the 1/2s cancel. And what is 1 over 2 root x plus another 1 over 2 root x?
2 over 2x.
It'd be 2 over 2 root x over root x plus 1 squared, which is 1 over root x times root x plus 1 squared. So the algebra is a little bit trickier that way, right? And the problem there is you have a fraction in the numerator, right? Like a fraction within a fraction. So you can multiply by root x over 1, root x over 1, and it gives you that answer. I think taking out greatest common factor is easier, but the other way does work. But I think a lot of you could have messed up what this plus this is, right? I think that would have been tricky for you to kind of abstract. But just think, if you do x plus x, it's 2x, right? Thing plus thing is 2 thing. And the thing is 1 over 2 root x. Thing plus thing, 2 thing. Okay. Alrighty, this guy. So these rules get tricky when they get combined. And here's an example of them being combined. So I'll do this one really slowly and we'll simplify it together. So f prime of x is, what rule do you have to use? Well, actually talking about the rules, but the first thing I see is a ratio, right? So a ratio means quotient rule, right? Okay, so low, which is x plus e to the x, d high x e to the x. I'm going to put a prime there, which is me telling myself I've got to take a derivative of that eventually. Does that make sense? Low d high minus high d low all over low squared. Does everyone get what my prime signs mean? They mean one must still take a derivative. Okay. So you have x plus e to the x. This one is complicated. Why? It's a product, which means you have to use the product rule. Even though it's embedded in a different problem, that's when people start to forget. They're like, oh my gosh, it must just be 1 e to the x. That's wrong. What is the derivative of that going to be? No. Use the product rule. Differentiate the first thing, first derivative is 1. E to the x gets left alone. Plus, there you go. Okay, I needed the parentheses because the whole derivative is being multiplied by that other thing. Minus x e to the x. Is the derivative of x plus e to the x tricky? No, that's just 1 plus e to the x. All over x plus e to the x squared. Okay. I don't think I see any greatest common factors at all. So you have to multiply these things together. Okay, so let's just do the x first. X times e to the x will be and then x times x e to the x is x squared e to the x. What is e to the x times e to the x? Plus x e to the 2x. And then minus x e to the x minus x e to the 2x. Okay, does anything in the numerator cancel? X e to the x cancels that. And anything else? the x e to the 2x. Yep. And you're left with x squared e to the x plus e to the 2x times x plus e to the x squared.
What always pays for terms of the cancel?
Oh, no, not always. No.
It's not a pattern on all.
Nope, it's not a pattern. I mean, this one does have stuff that cancels, but it doesn't always happen.
Yeah, kind of like the limit things we were doing before.
Yeah, the limit things, there definitely was some, things always should have worked out well, as in like the things that had the h should have always canceled, but with this, not always. One more thing you can do, just want to make one more step, is there is a greatest common factor in the numerator. What is it? Then you got x squared plus e to the x. That's another skill you're gonna need. So I'm probably gonna like require that you take out greatest common factors on quizzes. Does that make sense? And you'll get most of the points if you get the derivative all simplified correctly and stuff like that. But I'm gonna make you take out greatest common factors. But I'll specify it in the directions. If I don't specify, you can lawyer me and I won't make you do it, right? I mean, but the point is, we will ask for that. Okay. So, suppose that f of 5 is 1, f prime of 5 is 6, g of 5 is negative 3, and g prime of 5 is 2. Find the following values. So, f minus g prime of 5. Is the rule for subtraction and taking derivatives complicated? No, it's not. So f minus g prime of 5 is the same thing as f prime of 5 minus g prime of 5. Like that's it. The rule for addition and subtraction, easy. What's f prime of 5? Minus g prime of 5, which is, so this is 4, okay? There you go. Alrighty. How about this one? Fg, so f times g of prime of 5. So what rule do you have to use for that one? Product. So that will be f prime of 5, g of 5, plus times f of 5. Great. And the order of that last term doesn't matter, does it? Like she could have written f of 5 first and g prime second. Oh, it doesn't matter. Yep. If you want to put your derivatives first and your regular functions second, it does not matter in the end. Okay, f prime of 5 is 6, right? G of 5 is plus g prime of 5 is 2. F of 5 is, so I think negative 18 plus 2 is negative 16. Okay. Last one. G over f. It's a little bit confusing because instead of writing f over g, I wrote g over f, right? Which means the rule is, I just think it's easiest to use the low d high thing, right? So low d high minus high d low all over low squared. Rhymes are good. Yes? Rhymes good? I like rhymes. Yes. Then just plug your numbers in and go. What's f of 5?
1.
G prime of 5 is
2.
Minus g of 5, which is times f prime of 5, which is all over f of 5, which is 1 squared. So I think we'll just have 2 minus negative 18, so 20. Before we go to the next page, I want to add in one small thing because it often confuses students. So students, when they see the product rule, think that they have to use the product rule for constants. So what is the derivative of a constant times a function.
Constant times the derivative.
And the question is does that jive with the product rule? Does that make sense? Because so if you applied the product rule to this, so suppose you forgot that that was a rule, and you're like, oh my gosh, I'm not sure what to do with that function. You would take the derivative of the constant times f of x plus the constant times the derivative. Do you see how that would be using the product rule? Like c is my first function, f is my other function, right? What is the derivative of a constant? 0. So you have 0 times f of x plus the constant times the derivative of f of x. What happens to that first term? And that will happen for any constant, right? So there's no need to apply the product rule when you've got a constant times a function. The constants just factor out and you account for them after you're done taking the derivative of the function itself. See what I mean? Okay. Often when students they make a mistake differentiating the constant, like, oh my gosh, the derivative must not be 0 because it can't go away. That must be so strange. No. Okay. Okay. All right. All right. Find an equation of the tangent line and normal line to this curve at this point. So the normal line, remember that's perpendicular to the tan line, right? Okay. So y prime equals, does this 2 matter? Not really, right? So we're just going to leave it alone, and we're going to take the derivative of this product. Because that product expands to 2 terms when you take its derivative, I'm going to put the result in parentheses. Okay, so what's the derivative of root x? 1/2 x to the e to the x plus root x e to the x, right? And what's the derivative of that 1? 0. So y prime is 2 times e to the x over 2 root x plus root x e to the x, or it's e to the x over root x plus 2 root x e to the x. Okay, I'll pause, let you catch up, but just... Is the derivative part okay? Differentiate first, not the second. First alone, differentiate second, right? Okay, at the point 0, 1, for the tangent line, how do you find the slope? Plug in 0. Oh, and what happens in this, I did this on purpose, so it'd be a little bit tricky. Yeah, what happens when you plug in 0? You can. Rachel's shaking her head. So that means the slope is undefined, which means your tangent line is vertical. Does that make sense? So if your tangent line is vertical and it goes through 0, 1, that's over nothing, up 1. What does the line have to be if it's going to be vertical and go through that point? It's not an asymptote, it's just going to be x equals, what's this equation? X equals 0. So if the tangent line is vertical, what's the normal line going to be? Horizontal? Will look like this. What's its slope going to be? 0. So to be y minus 1 equals 0, x minus 0, or just y equals 1. You can say it goes to the point 0, 1, so it's the equation of y equals 1. Hopefully most of the time that won't happen, but if you do get an undefined slope, my point was that means it's a vertical line. So plot what your point is and figure out what vertical line goes through that point. And you could graph this function. You're going to see that as your function approaches that value, it has one of those. This is what you have with functions like, didn't we talk about the cube root of x? The derivative doesn't exist at 0 because the tangent line is vertical. And if you were to take the derivative of this, you're going to get a 0 in the denominator. And you've got this infinite slope or vertical line thing going on. So if you were to graph that original function, it's going to have some kind of thing where it goes vertical-ish as it approaches 0. So the tangent line equation just happens to be a vertical line in that case. Does that make sense? So here the tangent line equation is a vertical line. And then the normal will be a horizontal line. Okay. And then just a couple more applied questions and we'll take a break and do the next lesson. So a manufacturer makes socks because you're mature and so you make socks instead of teddy bears. So, and the quantity of these socks is a function of your selling price. If you price your socks too high, you're not going to sell very many. If you price them low, it'll be a great deal and you're going to sell a lot more, right? There's a good price in the middle where you're going to sell maybe not the most, but you make more money per pairs of socks, okay? So this thing is Q equals F of P. Q being quantity, P is price. Okay, so what does it mean to say F of 10 is 20,000? So this is the regular function. So that means P equals 10. So what does that mean about your socks? So price of socks is $10. You sell how many? Q equals 20,000. I assume they're sold in pairs. Okay. That's what that means. Does that make sense? Okay. So for f prime of 10, so saying when P equals 10, the slope of the tangent line is 3500. It will be really helpful to get its units, okay? Because I think they'll help you make sense of what it means. So slope has units, y's units over x's units, right? What are y's units? Socks, or number of socks, right? Socks per, what are p's units? Okay, socks per dollar. Which means the number or quantity of socks being sold is increasing at 3,500 socks per hour. What am I saying? Socks per, what were the units, sorry? Dollar. So even though your price is going up, you're still selling more socks. Which means you want to make those socks cost more. You're making them exclusive. People are like, ooh, these are fancy socks. I'm going to spend a lot of money on these fancy socks. Okay, so that's what the mean. I think with these derivatives, the useful thing is units are y's units over x's units, right? Positive means going up, negative means going down. If that price started to go down, maybe you would consider leaving the price at that place where it was. Or the quantity had started going down, you would like leave it back where it was. Okay, second part says the total revenue is P times F of P. So this really is the same thing as P times Q, where P equals price and Q equals quantity. You guys know what revenue means? It's like how much money you pull in at the end of the day before taking out your costs. Does that make sense? Okay. So assuming the values in part A, find r prime of 10 and interpret your answer. So if you have r of p equals p f of p, can you use the product rule to get f prime? What's the derivative of p? Not 0. 1. It's not a constant, it's a variable. 1 times f of p plus p times f prime of p. So r prime of 10 will be 1 times f of 10 plus 10 times f prime of 10. So what is f of 10?
20,000.
Plus 10 times, was that 3,500? So that's 20,000 plus 35,000 is 55,000, right? So is your revenue increasing or decreasing? Increasing by $55,000 per $1 increase in price. No, this is the slope. And that's, I probably should add when p equals 10. So it's at that particular value, at that particular price, is revenue going up or going down as the price price goes up. And the tricky thing about this one is units are funny because revenue is measured in dollars, right? And your P is measured in dollars, was dollars per dollar. Does that make sense? Okay, so that's it for this lesson. Let's take a 5-minute break. If you have to use the restroom, you have to go down to the bottom floor because this bathroom is under construction.